Okay. So we have these expressions for these two functions. Well, f of g of -1, you got to do g of -1, right? Well, that's f of 2 to the -1. Because g of -1, you're replacing x by -1, you get 2 to the -1. Most of you got that. So it's looking pretty good. To the -1 is 1 over 2 to the 1. Writing it out explicitly, you don't need the 1 there. I want to be sure you connect this with the rule for negative exponents. And then f of 1 over 2 to the 1 is 2 to the 1, just 1/2, and I'll write it this way. It's 1/2 squared, so you're going to plug the 1/2 in for x. And there you have it, right? And I already got that. Good. If you didn't get that, that's what we went over first week, okay? Make sure you review it, make sure you know how to do it. Okay. And then g of f of 2, what are you doing first? That's g of 2 squared, because f of 2, you're going to plug 2 in for x, you're going to get 2 squared, which is g of 4, which is under the 4, because g of 4 means you plug 4 in for x, 2 to the 4th is 16. Okay. Now those two are very straightforward. I think the vast majority of you got those. Okay. So that's a good start. Okay. F of a plus b is what? Well, you're going to plug a plus b in for x, right? So x is a plus b, so you're going to plug the whole a plus b in there and square it. That's not a squared plus b squared, so I hope you didn't do that. If you did, ponder what these things mean, okay? X is being squared. X is the whole a plus b, and the whole a plus b is being squared. And when you square a plus b, you don't get a squared plus b squared. Okay? That is a plus b multiplied by a plus b, which is a squared plus 2ab plus b squared. And you should know this derivative law well enough to be able to do that multiplication. If you don't, I need to review the derivative law, although at some point I'll probably work it out. I think I already have in an earlier class. Okay. Then what's g of f of x? Well, f of x is x squared, right? So that would be g of x squared. Okay. And what's g of x squared? Well, you're replacing x by x squared. If you replace x up here by x squared, you're going to get 2 to the x squared. And don't try to write that any other way. Write it exactly as it works with substitution. If you think you know how that simplifies, you might be right. But you have to understand the laws of exponents pretty well and have to be pretty careful with that kind of an expression. So just be literal, because otherwise you're taking a big chance of making a mistake. Now later, we'll have to simplify that. We'll have to apply the laws of exponents. You should theoretically be able to do that now, and many of you I'm sure can, but be careful with it. Okay. And f of g of x is what? Well, g of x is 2 to the x. And now if you do f of 2 to the x, you're replacing this x by 2 to the x. And that's 2 to the x squared, which looks like it's the same as this, but it's not. By the laws of exponents, That's 2 raised to the 2x, not to the x squared form. Because when you do a power of a power, you multiply the power. So you really have to know those laws, those rules. Otherwise, you're gonna mess things up at some point. Probably several points. Okay. Now, another alternative way of writing these out is g of f of x equals, well, you can do this by looking at the x function and replacing f of x with what the x function is. But you can also do it by looking at the g function, where this replaces g of replaces x, the f of x replaces the x up here. Okay? And if f of x replaces this x, you get 2 the f of x. And then you can take the expression for f of x and you get 2 to the x squared. And of course, it's the same as what you get up here. So it doesn't matter which order you did it in. Okay. And then f of g of x equals, so g of x is 2 to the, that's our f of x is x squared. So treat this as replacing the x up here with g of x. That would be g of x squared. Okay. And of course, g of x is 2 to the x. So this is 2 to the x squared, which is again 2 to the 2x. And it agrees with what we do. So it doesn't matter which order you do these in, you're going to get the same thing as long as you do it right. Now be careful of things like thinking really bad looking G, it's hard to write down here. Okay. So it's not this, it's not this, it's this. It's what you write down literally. Now there is another way of writing it. It's kind of related to one of these, but I'm not going to talk about that one. I don't want to confuse the issue. Okay. Be very careful and meticulous about the way you substitute. Okay. Some people did pretty well with this, and the people who submitted the homework did pretty well. As I say, I'm going to allow you to submit that, well, I want you to do it before the transformations assignment. So I'm going to pause the video here and see what that is. Okay. Now, let's see how much we get all the way over here. Okay. So here, so to sketch a smooth curve through these points. I'll leave that on the board there. Okay, so biggest number I need on the x-axis right now before I can shift things a units in the horizontal direction is going to be c. Okay, but I'm going to need then to shift that a units in this direction. So whatever c plus a is, I should have it on the graph. Okay. And if you look forward, look ahead and kind of know what's coming up from what we did last time. It'll save you a little time. Okay, so if A is 6 and C is 9, then we would need 15 out there. Let A be 7. We'll do 15. Okay, so there's 15. Now, let's say B is -8. So that's 15, then -16 would be maybe right here. -8 would be maybe here. Okay. So if A equals if B equals 8, B equals 9, then what's going to look like this? Going to have negative B, D. Well, D is A plus C, which is 15, right? So I'm going to go as high as D. Now nothing else goes that high, so I've got to get up there. Just a coincidence that this number is the same as this. Okay, so 8, that is a coincidence. 8, 15. Then you have A negative C, which would be 6 negative 9. In my case, if these were my, if that was numbers in my name, or if those were my numbers. Okay. So A would be 6. Well, 15 is here. So I kind of divide this into thirds. So this would be 5. So 6 would be about here. Then we go to negative C, which would be negative 9. Well, if 15 is here, I could say, okay, well, this would be negative 15. So now I can get negative 5 and negative 10. And negative 9 would be about here. So we can see that this looks like it's probably 6. Negative 9. And this is negative 18. Then CB would be 9, 8. So let's see, here's 10. So 9 would be about here. Here's 15. Half of that would be here. 8 would be about here. And there's my point. Now, the directions I gave you on the assignment were to sketch a curve representing a function. Okay? Now, if your curve didn't represent a function, I'll probably still give you full credit, but I'll also give you a note that says, hey, that wasn't a function. Okay? So if you do your curve like this, does that represent a function? Vertical line test. Or if you say, you know, what's the value of this function when x equals 7? Well, it's either this or this. You can't have an either or. It's got to have a value. You can't have two values. Okay? Which is why you have the vertical line test. So this is not a function. We're not going to use that. Most of the curves that I've seen, most of the curves I saw here look like that. They weren't functions. Now, in the directions I gave you today, I didn't say make it a function. Okay. Then, yeah, I'm really okay with whatever curve you draw for right now, but on the homework, remind yourself of what a function is, okay? Okay, I got to do something here. I'm not getting the whole screen. Is it in focus here? Sort of. Okay. Okay, so the curve I'm going to draw has to go through this point before it goes through this point, right? So I'm going to do this. Make it a real pretty curve. Instead of trying to angle it down here and twist it around to bring it back up there and make it look a little weird, which is okay if you do that. I didn't say not to. As long as it's a function, I'm totally happy with it. Okay. But this is a nice smooth curve. And if it has a sudden change in direction, I mean, just that's not a smooth curve. That's not smooth. If it has a quick change in direction, not real, not sudden, it's okay. Okay? But by a smooth curve, I mean something. Okay, this is smooth. Nope, not smooth. Drop that away from me. That's smooth because of this sudden change in direction. Now, if it changes direction, let's see if I can. Smooth. Okay. Doesn't have a point on it. Doesn't have a corner. If you run into it, it doesn't hurt as bad. Okay. Okay. Well, right there. No graph, so we're going to shift it horizontally. Bay units. How far is that? Well, in my case, it's 6 units. Okay. So this point will come over 6 units. I haven't located it exactly right, but we've got to come over 6 units. So I'll have a point or something like this. This point will come over 6 units. Here, and this point will go over 6 units, maybe 2. Here. And now, my curve looks like this. Same shape. And of course, you can't draw the curve twice in exactly the same shape, but as long as it doesn't look a whole lot different, it's good. Okay. You know, do your best to make it the same shape. Because now this represents the curve where every one of these points is shifted over 6 units. Now, as we've said, if this curve is y equals f of x, this curve is a y equals f of x minus 6. Okay. And we talked about why it's f of x minus 6, because x has to be 6 units bigger to give your points, to make your points over here. In order for x minus 6 to have the same value as x had over here, x has to be 6 units bigger, and that's what shifts your graph to the right. Well, okay. Then we move each point twice as far from the x-axis on the same side. Now here's where I kind of shot myself in the foot because I made this graph big, and I can't move these points twice as far. Maybe this one, but this point would be up off the board, right? And this point would be down below here. Okay, it's pretty solid. I don't think I can get through that. Okay, I'm going to try. Don't damage the board. Now, so what I'm going to do, I'm going to represent that transformation a little differently. Now, if I'd have been smart and anticipated what was happening, I'd have seen, well, I have to move each point twice as far. So I wouldn't have put 15 all the way up here. I'd have put it down here, and the graph would have looked flatter. It still represents the same function. I'd have had room to do everything. But since I didn't, I'm just going to take points on this curve because it's moving of these points, the points that we got here on the purple curve. I got to move them twice as far from the x-axis, right? Well, I got to take some points that I can move twice as far. I'm going to take this point. Let's see how far can I get. I can go to this point, and then maybe this point, and this point, and even this point. Okay, so take each of these orange colored points and move it twice as far. How do I do that? I take an arrow from here to here, and then I take an arrow the same length And now I've got a point. You'll agree that if these arrows are the same length, this point is on this graph, right? It's not one of the given points because I messed up and didn't do that. But really, I didn't care because I know I could do that with 100 points. Okay, I just can't show the whole graph because I'm going to be able to show this important part of the graph. Okay, well, I do that with this point. Got to go on the same side. So on the opposite side, we have to take two arrows of this length down this way, right? Or here, we take two arrows of this length up this way. So here. And here. And here. And here. Now those new points really would have been better, but it gives me a different color. I'm going to get confused about which points to connect. If I've got two orange points, I'm going to connect from here to this point or from here to this point. Well, now that they're blue, I can do that. Well, that's not, I hope. Okay, so we start with this point. We come down through this point and this point. And then we're going to turn around down here someplace. And imagine doing that. And it would go all the way down to about here. And then we come back up here. So starting to turn maybe, and then up here, starting to turn a little bit. And coming up pretty fast through here. And here. Okay. So this would be graph of 2 times f of x minus 6. All right. Now, another thing I could have noticed, I would have been thinking, and want you to think about it. I don't want to say anything about it, just to see how it came out. Connecting these points, how far is this point on the purple graph from the x-axis? Well, it's on the x-axis, right? It's a distance 0. What do you get if you double a distance of 0? You get a distance of 0, meaning that the point on the blue graph should go through here. Now, coincidentally, this point did go through like it should. This was close, but since I'm doing this graphically and just doing an honest curve, it kind of missed here. I could have said, well, this should be a point on the blue curve. I'll make a big X there and make it look almost like it's through the X, so you won't think I made a mistake. Okay, it wasn't really a mistake. It's just the graph is not exact. The shape is not exact. Over here, it worked out pretty well. So when you're multiplying a function by a number, the points where that function goes through 0 aren't going to change. It's just the function's going to stretch out as it did here. You can see how that blue graph is a stretched out form of the purple graph, right? It looks skinnier. Okay, so then stretch this way. If I just stretched it by a factor of 3, well, that'd be 3 times this, and it would be even skinnier, and the points would be even further. I had to do 3 arrows, right? Okay. Well, you want to understand that, and you want to understand and relate that to these expressions for the function. Okay? Because in applications in the real world, we often have to add functions or subtract them or divide them or multiply them, or in this case, transform them by these sorts of transformations. Okay. You'll also see a stretch we stretch it in the horizontal direction or compress it. Okay, every point would move, say, twice as far from the y-axis, and maybe on the other side. What we did earlier. Okay. Now, to connect this. Alpha x plus 2 equals what? That's 1 over x. So please answer that question. Don't be looking at something else. I'm trying to wait till we can do this. So, whatever you're working on looks pretty good. We're not talking about a table for x plus 2, which the three of you are doing. We're talking about the expression f of x plus 2, right? Equals what? Doesn't equal a table. Although it'd be good to make that table, okay? It equals an algebraic expression. So you want that fraction sign to go all the way over this. Doesn't this looks like 1 over x added 2? Okay. The whole x plus 2 doesn't mean none. That's it. Okay, good. That's the right idea. Okay, you gotta be careful. Huh? Okay. Most of you either got it or more. Okay, I'm not sure what happened to the recording. Let's make sure. If f of x is 1 over x, the graph of f of x plus 2, just the graph 2 units this way, because in order to get the same value, the same y value, x has to be 2 left. If you're adding 2 to x, then this will give you the same y values if x is 2 left. Then that's right. And the x and this, yeah, a lot of words there. So we graph the basic function, which we know how to do. Okay, so you're going to have to do it. I guarantee you next time there's going to be a quiz where I ask you to do this with basic function. So the basic function consists of these 6 points, basic f of x function. And then we can do the extended basic function by sketching a curve. Right? Okay. So we know how to do this, and hopefully know how to do this. Then we move each point 2 units to the left. Now we can move it negative 2 units in the horizontal direction. So I've got here a bunch of arrows of length -2, indicating the displacement of -2 horizontal units. And here, here, and here. So I get this point, and this point. And this arrow approximately shot something, apparently shot something that headed should have been a straight line. Okay. So we get these 6 points, and then we connect those 6 points in the same way we connected these, and we have the extended basic function f of x plus 2. Then, what is the expression for f of x plus 2? Well, here's your expression for f of x. What replaces f x up here? X plus 2, right? And where does x go? It goes underneath 1 in a fraction. reciprocal of whatever x is. Okay, so if x is x plus 2, if x is replaced by x plus 2, then we've got to put x plus 2 here in the denominator. Okay. Now, a lot of you almost wrote this correctly. I saw at least 2 or 3 cases where people wrote 1 over x plus 2. Do you understand what's wrong with that? There's something right about it because you're trying to do the right thing, but you're not putting x plus 2 where x was. You put the x of the x plus 2 under 1, then you're slapping the 2 off out there somewhere later in this expression, right? So you got the right idea, you just made a mistake with the idea. Okay, make sure you're very literal in where you put these things and how you substitute. Okay, in order to do this, you have to see that negative 2 over x is negative 2 times 1 over x. What does it do to a graph if you multiply the function by negative 2? Well, what does it do? Here, it moved every point twice as far from the x-axis, but on the opposite side, which we did in an example last time, right? So okay, y values will be negative 2 times the original because you're doing the 1 over x function, right? This is a multiple of the 1 over x function. If all the y values become negative 2 times as great, that means they get twice as big, but they also change sign, which puts them on the other side of the x-axis. Okay. So, see if you can sketch that. Okay, I get mixed results here. Some people understand, and some people just, haven't yet digested everything that we've been talking about. So if you haven't digested it, then you can digest it through the open math, digest it by looking back at the videos and looking carefully at the things you might have missed and didn't understand. But it's very important stuff, so try to get it. Okay, so this point here has to go twice as far on the other side of the x-axis, right? So this point is this far from the x-axis, right? Take an arrow of this length, and you've got a point at an equal distance on the other side of the x-axis, right? But it's not twice as far, so you're going to have to use another arrow. We'll put you down here. Okay, well, this point is here. You do an arrow of the opposite, in the opposite direction, same way. This is here. Put you down here. And same thing with this arrow. And here, and here, and it gives it a point like here. And well, they are, they're green. That's not an X. That's confusing at all, but I need better. Okay, then here, there's an arrow that shows you how far in and what direction this is from the x-axis, right? Reverse the arrow, facing the other side of the x-axis. You do 2 of them, twice as far. Here's the point. Same thing here. The better Calvin, I can go. Don't do any worse than I do, it's still, if you do worse than I do, you do. Yeah, that's that cross straight line. I take it all the way up here, and 2 arrows. This is there my point. Now, if we want to back the curve, I have to move my base. In here is my transform basic function, reflected on the other side of the axis and stretched out twice as long, right? Okay, and this is the standard basic function for y equals 1 over x. And this one is you think of it as I should give myself room. No, I didn't try it. I never give myself room. Okay. Y equals -2 f of x, and f of x is 1 over x. It's -2 times 1 over x, which is -2 over x. That's the function. That's what we originally had, right? Yeah. Right. Okay. And here's again y equals -2 f of x equals -2 times 1 over x equals -2 over x. All right. Now, hopefully we understand this, or if it's still kind of a booming, buzzing confusion, we're on our way to sorting it out, okay? And it's up to you to do that. You don't have a heavy assignment for the weekend. You do have 2 things. One is the section on transformations, and the other is just do this stuff and make sure you got functions, okay? If you don't have functions, again, I'll just explain a little bit, maybe take a point off. But ultimately, if I put this on a test, and it will, if you don't have a function, it's going to be a little more heavily penalized, okay? Probably 1/3 of your credit will go away. Still, as long as you're transforming things correctly, that's the main idea, okay? Okay, and then, as I say, a week from today, I have to drive up to Charlottesville and back, okay? Not a big deal, but I'm gonna be going. So it's very likely that I'll have some sort of quiz I want you to go to the testing center and do. Okay, when you get used to the testing process, this counts basically as a quiz unless you don't do it, in which case I'll destroy your grade. No, we'll do that. But you're required to do it. It's a requirement. You won't pass the course unless you take a quiz. Okay, even if the points aren't that heavily counted. So you'll have a window anytime between that Tuesday and the next Tuesday, if you take the quiz before class. It's good, just don't get behind on the other homework assignments. Fair enough? Then we'll have a homework assignment for that following Tuesday, so stuff we'll go over this Tuesday.